Two non-decreasing sequences of non-negative integers have different first terms. Each sequence has the property that each term beginning with the third is the sum of the previous two terms, and the seventh term of each sequence is n. What is the smallest possible value of n? We'll start by looking at these sequences. So we'll call this first sequence the first term being a, second term being b. Then with the third term, that's the sum of the previous two terms. So this will be a plus b, and then this term is going to be the sum of this term and that term. So we'll have the fourth term and then the seventh term is going to be 5a plus 8b. And this other non-decreasing sequence, we'll just use different variables. We'll use x and y. Okay. So since these are non-decreasing, it has to be true that b is greater than or equal to a, and y is greater than or equal to x. And so these are the seventh terms that we're focused on. So it also has to be true that 5a plus 8b is equal to 5x plus 8y. So these need to be satisfied. I know that both 5 and 8, the least common multiple there is 40. And we could set the following equations up. This is true. That equals 40 and 5. That equals 40. However, the only issue with this is that, yes, this 5 is greater than 0, but 0 is not greater than 8. So right here, this doesn't satisfy that condition. The number that's 8 is multiplying by has to be bigger than the number that 5 is multiplying by. So for that reason, this doesn't work. But this unveils an interesting property, basically that when we add 8 to the number that 5 is multiplying by and subtract 5 from the number that 8 is multiplying by, we'll have no change in this end result. So basically, I need to find that this number 5 is multiplying by something, 8 is multiplying by something, such that when I decrease the value of this by 5 and increase the value of this by 8, it leads to either these two numbers being equal or this being greater than that number. And it's going to be the case that when we multiply 8 by 13 and 5 by 0, I'll explain why this is minimizing, because again, we're trying to find the smallest possible value of n. I'll explain, it'll become clear why this is the smallest possible value of n. So when we increase the value of this by 8 and decrease the value of that by 5, here we have, yes, 13 is greater than or equal to 0. This is 104, by the way. And this result is not going to change because we decrease this by 5 and increase this by 8. So the net change is 0 here. But now what happened is 8 is greater than or equal to 8. It's equal to 8. And this is 104. And the reason why this works, this is minimized because it ensures that these two are equal and this is greater than or equal to that. It's minimized because let's say we wanted to do instead 5 times 0 plus 8 times 12. Yes, this is a smaller value, but what happens then is if we want to get the same result of 96, we add 8 to what 5 is multiplying by and subtract 5, and then all of a sudden 7 is not greater than or equal to 8. So this is the smallest value of what we can multiply 8 by, such that this number is greater than or equal to that number. And you can play around with numbers. You'll find that this is really the only combination. Again, like we could do this 5 times 1 plus 8 times 14, and yeah, we add 8 there, subtract 5 here, and again we've achieved this, but what this number comes out to is going to be greater than that number. This is the smallest possible value of n for that reason. And so, yeah, there you go. Smallest possible value of n is 104. So the answer is choice C.